This is lesson 1.7, the nth term formula for an arithmetic sequence. The learning target is I can write the equation for the nth term in a sequence and use it to find term values. So before we move on to today's nth term formula, we are going to quickly review the recursive routine from the last lesson. So when you have a sequence or a pattern, in the recursive routine, the only pieces of information that are going to be changed are D, which is the common difference, and the number, which is the first term. So the first number you have in the pattern is not always going to be the same, and the common difference is not always going to be the same. You are either adding or subtracting, so your common difference is either plus or minus. So if I look at this pattern here, to get from -1 to 8, I have to add 9. Now make sure you check your pattern between all the numbers before you identify your common difference. 8 plus 9 is 17. 17 plus 9 is 26. So my common difference is plus 9. The first term in my sequence is -1. So once I have those two pieces of information, I can write the recursive routine. Everything that is not circled, these two things are the only things that are going to change. This one is just to remind you that I'm looking only for the first term. Everything else stays the same. So to write the recursive routine, a of n equals a of n minus 1. My common difference is plus 9. So plus 9. And then all I need is a1, which is my first term. And the first term in this sequence is -1. Everything else stays the same. So anytime that you are writing a recursive routine, these are the only two numbers that are going to change, depending on what the difference is between your numbers or how the pattern is created and what the first term is. So find the value when n is 7. So this is n is 1, n is 2, n is 3, n is 4. Remember, n is the order it is in the pattern. So this is 1, 2, 3, 4. I'm looking for 7. So if I continue my pattern, I'm looking for the number that would go here under 7. So 26 plus 9 is 35. Plus 9 is 44. And then plus 9 is 53. So when n is 7, or the 7th number in my pattern, is going to be 53. What if I want to know what happens when n is 100? Well, that's a lot of work, because that means I need to know 1 through 99 to get 100. So when we need these bigger numbers, that's when the nth term formula comes into play. When it's smaller numbers like this, you can just keep the pattern going. But when they're asking you for the 100th or 250th term, it's going to take some more work if we use the recursive routine. When we're looking for big numbers, that's when the nth term formula comes into play. So the nth term formula can also be written like slope-intercept form, right? Remember, f of x is the same thing as y equals mx plus b. So this is the same thing as this. When we look at it in terms of f of n, d is still the same thing. D is still the common difference. And then we need a of 0 instead of a of 1. So we're going to work on that in a second. When we look at it in terms of mx plus b, remember m is slope and b is y-intercept. So they use different variables, but you would be writing the same equation if you wrote it in mx plus b form versus d times n plus a sub 0. So we can do part of this in the calculator. So the first thing we do is add a calculator. So home screen, you can do new document or the calculator down here. Do not use the calculator in the scratch pad. I will do new calculator, we never save, add a calculator. Then we hit menu. It's going to be a lot of the same steps that we've already done. And then number 6, which is statistics. Focus on the words, not the numbers. And then after statistics, we're going to do stat calc or stat calculations. And then this is still a linear regression. So we want the mx plus b. That's what we have right here, mx plus b. So make sure that you choose the correct linear regression because there's another one underneath it. We want the mx plus b. And then we have our x list and our y list. So these are the same steps that we've done before to get the equation. The exact same steps. Calculator, menu, statistics, stat calculation, linear regression, mx plus b. And then you put in your x and y list with the braces and commas in between. So, example 1 says write a formula for the nth term of the arithmetic sequence. So this is my sequence or my pattern, right? We already did that using the recursive up here. But now we're going to write it in terms of the nth term. So I am going to take these numbers in my sequence and I'm going to create a table. Right? Everywhere you see a comma, that's where the line goes. So this is 1, 2, 3, 4. I have 4 numbers in my pattern. This is n. This is the term value. Or this is x. And these are y. So, for the recursive routine, we already wrote it up here, so I'm just going to copy it down because I already know what it is. A sub n equals a sub n minus 1 plus 9, right? Because we said that in order to keep the pattern going, we have to add 9. It's the same numbers we had up here. But we also have to show what our first term is. Negative 1. Now, for the nth term formula, I'm going to use these calculator steps. So I'm already here. My x list is the top. So control, close parentheses for the braces. 1, 2, 3, 4. Control, close parentheses, negative 1, 8, 17, 26. I have 9 and negative 10. So remember, M and B are the 2 pieces of information that we need. But when we're writing it in terms of the nth term formula, M is the same thing as D and B is the same thing as A sub 0. So D and A of 0. D is the same thing as M. So my calculator tells me that M is 9. So therefore, the common difference is 9. That's my pattern, right? We already found that up here. The common difference is the same regardless of whether you're writing the recursive routine or the nth term. And then B is a sub 0, which is negative 10. We are not looking for the first term anymore. The first term is negative 1. That is not what I write here. A sub 0 is negative 10. So now that I have those 2 pieces of information, I'm going to write it in terms of a function. F of n equals D, which is the common difference. That's not going to change, regardless of whether you're writing the recursive or the nth term. 9, n. My a sub 0 is negative 10. So don't put plus negative 10. You just put minus 10. So this looks a lot like slope-intercept form. This is my slope, and this is my y-intercept. We're just writing it in terms of f and n. Now, it's asking us to find the value of the sequence when n equals 100. If I use the recursive one, I could do it, but it's going to take me a long time because I have to start at 1 and then go to 2, 3, 4, all the way to 99 to get 100. I want f of 100, so I'm just going to use this one because this one has an f. All I do is I replace n with 100. So this is part of the function lesson. Normally, I have n inside the parentheses, but now they gave me 100. So all I have to do is replace n with 100. So f of 100 equals 9. Inside the parentheses, I have a 100, so I'm going to put 100. Let me try to color code these and keep these the same. Everything else stays the same. All I did was I replaced n with 100. And all I have to do is put that in my calculator. 9, parentheses, 100 minus 10. I should not have written this n here. I replaced the n with 100, sorry. So my answer is 890. Once you write the nth term formula, or when you get the slope and the y-intercept in the calculator, the nth term formula will give you any term that you're looking for. You just plug it in. Example 2, write the formula for the nth term of the sequence. So I'm going to create my table. I'm going to find my common difference. I'm just going to do everything in my calculator. New document, don't save, add a calculator, menu, statistics, stat calculation, mx plus b. 1, 2, 3, 4, 7, 4.5, 2, negative 0.5. M is the same thing as D, negative 2.5, and a sub 0 is the same thing as b, 9.5. So I'm going to go ahead and write my nth term formula. F of n equals, D is negative 2.5, and this is positive, so plus 9.5. Once you have your nth term, the recursive routine is pretty easy because everything that's in pink is the only thing that's changing. A sub n equals a sub n minus 1. My D is going to be the same, minus 2.5. And then all I have to do for this one I'm looking for the first term. My first term in this sequence is 7. So this comes straight from the calculator. Once you know your M or your D, you use it the same one for the recursive routine, and then you just find the first term in your sequence, and that's a sub 1. So I want to know, find the value of the sequence when n equals 50. So all I'm going to do is replace n with 50. So f of 50 equals negative 2.5. Anywhere I have an n, I'm going to put parentheses. And if I have a 50 here for that n, I have to put a 50 here for that n. And then I just calculate it. Negative 2.5 parentheses 50 plus 9.5. And my answer is negative 115.5. The last example, example number 3, is very similar. So just use these two to help you with example number 3.